This lecture is going to cover section 1.7 on linear inequalities in one variable. We're solving linear inequalities. So inequalities, unlike equations, involve these symbols. Less than, greater than, less than or equal to, greater than or equal to are the four inequalities we're working with. The types of problems that we're going to have are, there's a few different kinds of inequalities that we'll work with, but we're going to solve them, and also many of the problems we're going to have to graph them. So let's start with this one, and this problem in the practice had an A, which was to solve, and a B, which was to graph. What I recommend, though, is that you do the whole thing and then answer the questions. So the inequality they're going to give you is for the whole problem. For this one, I got -29 is less than 3z minus 5 is less than or equal to 7. It's a compound inequality. I call it a sandwich sometimes, or a sandwich, because it's this variable expression, 3z minus 5, is between -29 and 7. It's between those two numbers, sandwiched between them. The way we work with these is very similar to the way we work with equations, where with an equation you do the same thing to both sides of the equation and you get an equivalent equation until it's simplified down to just variable on one side and a number on the other side, hopefully. We're going to do the same thing. I want to isolate the z, get the z by itself. And so the first thing I want to do is add 5. But unlike an equation, there are 3 places where I have to do it, not just 2. There's 2 sides of an equation, but this is a compound inequality. It's kind of 2 inequalities, but I'm going to solve them at the same time because it is one single expression. So the first thing is to add 5 to all 3 sides, because -5 plus 5, that's going to give me just 3z. That's the point. But over here, -29 plus 5 is -24, and over here 7 plus 5 is 12. And I've just got the same symbols, less than here and less than or equal to here. Now the last step in solving this, I need to divide both sides by 3, or all 3 sides rather, by 3. That cancels the 3 here. So I've got a multiple of 3. I divide by 3 to get rid of it. Well, I divide the other ones, so I get -8 is less than z is less than or equal to 12 divided by 3 is 4. And this is, in a sense, the solution of the inequality. If this inequality is what we're starting with, well, it's equivalent to this simplified inequality where z is between -8 and 4, possibly including 4 because of the or equal, but not including -8. Hawks is going to want you to answer in interval notation, though. Pretty much all of these, I think. They want you to use interval notation. We'll get to that in just a minute, but I want to address the graph of these. Now, a graph of an inequality in one variable is just a section of the number line. In this case, if I label -8 and 4, z is between those values. So I'm going to kind of shade in between -8 and 4. And then for the z, well, -8 is less than z, but z is greater than -8. I'm going to put a parenthesis. And that's the notation for greater than. So, or less than or greater than. Parenthesis this way or parenthesis this way. But this one, at 4, is not a parenthesis, it's a bracket. That's the graph. So I've highlighted, or I think on Hawks you have to highlight and place you have to choose the right punctuation, the right symbols to get started, but then you drag them to the appropriate places. You would drag the right bracket to the 4, and you would drag the left parenthesis to the -8. They are mismatched, but they're not, the symbols have a different meaning here. It means that we're including the 4 in this set, and we're not including the -8 in this set, but also all the numbers in between are included. This is where interval notation comes from the graph picture, and that's, I'm going to continue up here, because this is the answer to part B. Actually, for part A, they want the interval notation for this inequality, and it's -8, 4, with a parenthesis on the left and a bracket on the right. Again, the parenthesis corresponding to the less than, and the bracket corresponding to the less than or equal to. So this would be answer to part A. This graph here would be the answer to part B. And we'll do other problems similar to this one. This one is going to be a simple or a single inequality. 5y minus 25 is less than -20 plus 4y. So there's only one inequality sign in this. But it's still an inequality in one variable. The variable is y this time. I'm going to treat it almost as if it's an equation by subtracting 4y from both sides. First, 5y minus 4y is just 1y, or y. Minus 25 is less than -20, and then this is gone. Plus 4y minus 4y, there's nothing left. The next step, I'm going to add 25 to both sides to isolate the y. So minus 25 plus 25, all that's left is y. It's less than -20 plus 25 is positive 5. And that's really the solution of my inequality. But this is in the inequality notation. We're going to have to put the interval notation. I think the graph also. Yeah, they wanted the graph. But I find that it helps to build the graph before I try and do the interval notation, and then type into Hawks whatever they're asking for. But the graph and the interval notation are two ways of writing the same thing. The graph is a picture, a number line picture. The interval notation is a symbolic number line picture. So let's build this one. The only number I have to work with on this line is 5. Y is less than 5 means to the left of on the number line, but there's no lower limit. It's just, it keeps going. So on Hawks, what they're going to have is they might have an arrow here or something, but this is where -infinity lives. Not here, but that way, all the way down the number line, if you can imagine such a thing. Infinity lives over here, not coming into the picture here, because infinity is whatever it is, it's greater than 5. So it's not in our solution set. Also, at 5, I want to use the parenthesis to indicate that I'm including the numbers less than 5, but not 5 itself. That would be a bracket. This one's parenthesis. And then usually the number line picture doesn't have -infinity written there, but this does go all the way down the number line in the negative direction. We're going to denote that by -infinity. Practice writing it, but for Hawks, you're going to need to get the special symbol menu to get the -infinity, maybe a negative sign and just an infinity. It's something like that. So this interval notation is, as I said, symbol-made or symbolic picture of the actual picture of the graph, which is all the numbers to the left of 5, all the way down if we go to the left. And I'm going to use parentheses for negative infinity because we're not really including the number negative infinity. It's not really a number, but it's just the convention that we just use parenthesis instead of bracket. The same will be true if we have an interval that extends infinitely in the positive direction. That would be infinity, right parenthesis, not bracket. So there's the solution in interval notation, and there's the graph for this one. The next one that I got is called an absolute value inequality. So for number 3, 4 absolute value x plus 2 is less than or equal to 28. So this is a different kind of problem. It's an inequality, but it's got that absolute value thing going on. So we're going to have to deal with it a little bit differently. To start with, though, it's 4 times the absolute value expression less than or equal to 28. And I can get rid of that 4 by dividing both sides by 4. Balances just like an equation. Those cancel. I get absolute value of x plus 2 is less than or equal to 28 divided by 4 is 7. In fact, working with inequalities is almost the same as equations. The only thing is multiplying or dividing by a negative flips the direction of the inequality. I didn't see it come up in these examples, but when we see it, we'll look at it a little more closely. Now, I think the best way to interpret this statement, absolute value of x plus 2 is less than or equal to 7, is to think about x plus 2 as a number. How big can it be? Well, it can't be bigger than 7. But also it can't be less than, well, it can't be like negative 100 because its absolute value would be greater than 7, not less than or equal to. So it can't be too far into the negative. Specifically, it can't be below negative 7. If it was below negative 7, like negative 8, its absolute value would be greater than 7. So you've got to think a little bit about the sign of this thing. I'm going to rewrite it as an ordinary inequality. Well, it's an absolute value inequality. I'm going to write it as an ordinary compound inequality. X plus 2 has to be less than or equal to 7 to have an absolute value less than or equal to 7. But it also has to be greater than negative 7. Or negative 7 has to be less than or equal to x plus 2. It has to be sandwiched between 7 and negative 7 in order for its absolute value to be less than or equal to 7. And so I simplified one step, then I changed this absolute value inequality into a compound inequality with no absolute value. And this is the kind that I can solve. Actually, this is a one step. Subtract 2 from all 3 sides. Negative 7 minus 2 is negative 9. X plus 2 minus 2 is just x. That was the point. And then 7 minus 2 is 5. And there's the simplified ordinary inequality. It's a compound inequality, but there's no absolute value. It just says x is between negative 9 and 5. The graph would look like this. Negative 9 and 5 are the only important numbers on this graph. I'm going to shade between them because x can be between them. But a bracket for the 9 and a bracket for the 5 because they're both less than or equal to signs. And then finally, I'm going to write the interval notation over here. -9, 5 is the interval notation, both with brackets. The brackets in the graph and the brackets in the interval notation are the same. And they mean the same thing. So for the next one, it says the perimeter of a square must be greater than 110 inches, but less than 126 inches. Find the range of side lengths. So the range of the possibilities, or we're going to solve an inequality. There is a hint for this one. The hint says P equals 4S. And what it means is the perimeter, it's mentioned in the problem, the perimeter is the distance around the shape. In this case, it's a square, so there's 4 sides. The perimeter is equal to 4 times S, the length of one of the sides. So 4 sides is 1 perimeter for a square. And all the sides are the same because that's what makes a square. Okay, so I'm going to translate this sentence here. Not the first sentence. I'm going to translate that into an inequality. It says the perimeter, P, has to be greater than 110 inches. I could write P is greater than 110. What I'm going to do instead is write 110 is less than P. Same meaning, it's just that this way allows me to say also that it's less than 126. So rather than having 2 different inequalities, I have this one statement that says the same thing, it's just in one sentence rather than 2 separate ones. Now I'm going to swap out the P for the 4S because they're equal. That's called a substitution. I'm substituting 4S in place of P. We did that when we evaluated expressions, but this is substituting a variable for another variable expression. It's all right, though. It's exactly what we need to do. If I divide by 4, we can see, let's see. It's said to use decimals, I'm pretty sure. So I'm going to write 110 divided by 4. What I got from my calculator was 27.5. 4 and the 4 cancel, leaving S. And 126 divided by 4 is 31.5. So there's my simplified inequality with decimals. You can reduce these fractions a little bit, but they're not whole numbers. Finally, I'm going to put that in interval notation, 27.5, 31.5, with parentheses. This is my actual answer here. With parentheses because they're both strictly less than, or less than signs, not less than or equal to. That's the interval notation for the range of values that we can have for the side lengths. So the range of side lengths is any number between 27.5 and 31.5. right, so this next one is another applied problem, and it's a couple of sentences that will translate into an inequality again. It says gold status. I guess it's like a frequent flyer sort of thing, with an airline is less than 39,600 miles. 600 miles. But at least 14,400 miles. If Elliot takes 900-mile trips. In the problem, as I read it, he was going to see his parents, so it's the same distance each time, round trip, 900 miles. Each time he goes there, he's getting 900 miles toward his gold status. How many flights must he take for gold status? So how many of these 900-mile round trips does he have to take to be within the range for gold status? I guess if you have more than 39,600, they're probably going to say you have platinum status or something, but we've got a range here. I'm going to say that X is going to equal number of flights. That's what I'm looking for. How many flights? How many times does he have to go visit in order to earn the points? Okay, so 900x, that's going to be the main building block of my inequality. 900x is 900 times the number of trips. That's his total mileage. It's the number of miles Elliot earns from that airline. So 900 miles for each flight, and so the number of flights times 900. All right, so what we need to do is start our inequality. I don't want to erase this before I use it, so the last thing I'll do on the board here is get the inequality that describes this situation. The number of miles, 900x, I'm going to write that in the middle because it's going to be sandwiched between two values. The top value, or the upper limit, is 39,600, and the lower limit is 14,400. So his total number of miles is between those two values. Now there's one thing I want to change about this, because it really does say less than 39,600, but it says at least 14,400, and it does not mean that it shouldn't be a less than there. It means less than or equal to. The term at least is a less than or equal to type of actually, now what this is the number of miles is greater than or equal to 14,400. At least means greater than or equal to is the point there. Okay, so I need to get some more room to solve this inequality, but it is going to be kind of quick. Remember, x is the number of trips that he has to take to do this. 14,400 is less than or equal to 900x is less than 39,600. This is just a one-step problem. We need to divide all three by 900 to cancel those out and get just plain old x in the middle. The other symbols are the same, less than or equal to here, less than here. This quotient comes out to 16, and this quotient comes out to 44, and that's the inequality notation for the solution. That's not the interval. I'm pretty sure Hawks is going to want the interval. So it's between 16 and 44, but I want to include 16 in that solution set and not include 44. Because if he takes 45 trips, he'll be above the range for gold status. If he takes fewer than 16, he'll be below the range. But if he takes exactly 16, he'll be right at this mileage. And that's less than or equal to that number. So that's probably how Hawks is going to want you to put your answer in. The next problem is an application to academics. You've probably done something similar before. This is a pretty clear-cut way to use algebra to find, not to find an average, but to use a target average to find what your immediate goal should be. In this problem, it says Mark has 4 tests this term, or this semester. The first 3 are these scores: 75, 77, and 86. What range of scores on the 4th test will give him a B in the course? Between 80 and 89. Between 80 and 89 is what I mean by a B. So there's 4 tests, and that's it. The average is his class score. The average of the 4 tests is the same percentage or whatever for the score. I'm going to say X equals the 4th test grade. And we're going to build an algebraic expression out of X. So the 4th test grade is not known. We do know the first 3. His average is what we get when we add up all the grades and divide by the number of grades. In this case, we add up 75 plus 77 plus 86 plus X. We don't know what X is yet, but that's why we have a variable for it. Divided by 4. The average of 4 numbers is the sum of the 4 numbers divided by 4. All right. Okay, with that, I'm going to build the inequality that describes this. I don't want to erase the critical information. So this is what we need to build the inequality. Our goal is to get the average in the B range. That means the average 75 plus 77 plus 86 plus X divided by 4, that's my expression for the average, has to be between 80 and 89. And I'm putting the 80 over here because it's the only way that it makes sense with the less than. Otherwise, I'd be saying that 89 is less than 80. Now, you got to have the bigger number over here if your inequalities are pointing that way. Okay, one little modification though. I think if you get an 80, that's a B if it's the 80 to 89 range. And if you get an 89, that's probably a B also. If you get over that, you're in the A territory. But let's call these less than or equal to inequalities. And I'm going to solve this to figure out not the single value of the test grade, but the range of values for the fourth test grade that will keep this average in the B zone, or the B interval. So, well, I usually don't like to get into really big numbers, but it's going to make this a lot easier if we first get rid of this fraction. And we can do that, since it's just a number down here, we can do that by multiplying by 4. As long as we do it to all three places. Multiplied by 4. So here it's this sum divided by 4, and then times 4, they cancel each other. Now, I had to get a calculator to do these because the numbers are big. Well, 80 times 4, 8 times 4 is 32, but there's an extra 0, that's 320. I did that one in my head, but this one, I did not. I typed that in the calculator, got 356. And what's in between them? Well, we canceled the 4. We can write this whole thing again, but that's really another calculator situation. It's the 75 plus 77 plus 86 is 238. Plus x. The x we can't combine because they're not like terms. But those three numbers add up to 238. And I kind of did 2 steps at once. I multiplied by 4 and added up the numbers, but they weren't stepping on each other's toes or anything. The next thing I'm going to do is subtract 238 from all three sides. And here, this is the goal. 238 minus 238 is just the x. And x is between 82 and 118. These are 3-digit subtractions, so I used a calculator. You could do it by hand, but it's much quicker if you can find your calculator. And then this I can translate into interval notation. Because they're both less than or equal to, I'm going to use both brackets on the left and right. But if I get a score, if Mark gets a score, anywhere in the range between 82 and 118, then that'll keep his average high enough that he'll be in the range between 80 and 89, he'll get a B. Now, as far as putting this into Hawks, if they tell you this isn't right, I think they're probably looking for this, because 82 is the minimum score to get him in the B range, and 100 is the maximum score on the test, is what it seems like from the context. So they may be looking for this, which you could do on a 100-point test if there's extra credit. You could get it higher than 100, but they may just be looking for this answer too. The next problem I have is another solve and graph and interval notation problem. 8 over 4 is less than y plus 5 over 2 is less than 24 over 4. And in this situation, to keep it as simple as possible, I'm going to reduce these fractions. This 8 divided by 4 is 2, and 24 divided by 4 is 6. So I'm not really working with the inequality there. I'm just simplifying those expressions separately. All right, so the first step of working with the inequality is I need to multiply by 2. So it's y plus 5 divided by 2. And it's as if these are grouped. The fraction bar is a grouping symbol, so it's not, it's y plus 5, the quantity, divided by 2. But I need to multiply by 2 to get rid of that divided by 2. So multiplying on all three sides here, 2 times 2 is 4. Y plus 5 divided by 2 times 2 cancels and leaves y plus 5. And 2 times 6 is 1. So this is a less than and a less than. I've got a simpler sandwich than when I started. The last step is to subtract 5 from all three. And here I get -1 is less than, just y is less than 12 minus 5 is 7. So this is the algebraic inequality notation. This is the solution between -1 and 7. But for Hawks, I'm going to need to graph it. I'm definitely going to need to put it in interval notation, but I probably need to graph it too. The graph helps me keep straight what I'm doing for the interval notation. So if you build the graph, it's kind of a step-by-step thing. You can build it, shade in the area, and then these are both less than signs. So I want parentheses instead of brackets. There's my graph. And then from the graph, the interval notation, you're just copying the numbers and the symbols. The only thing you have to remember is the comma. That's the only thing that interval notation adds to it. It subtracts the number line part of the picture and the shading, which makes it a little bit neater, at least in my artistic ability. Okay, so the next one I have is, well, I found it tricky. So if you get one like this, and you can use my example as a template to try and do it, but I thought it was very difficult. It's another absolute value inequality, and I don't really have a systematic way to do this, because this one has not only a variable in the absolute value expression, there's a variable on the other side also. So the way I usually do it, it kind of worked. I don't think it was as smooth as it usually goes, but think of it like we had with the other one. The absolute value of the expression is less than or equal to this. Means the expression itself, 3t minus 3, is less than or equal to this. Has to be for its absolute value to be. But also greater than the negative of that. So it has to be this one bigger than -t plus 7. Greater than the opposite of it. In other words, this 3t minus 3 is between, well, that's just as it is, but also between that and the opposite. So it's sandwiched between these two, and I've made it into a compound inequality instead of an absolute value. And it doesn't look simpler. It's simpler though. Without that absolute value there, we can just add and subtract things. Like here, I can't add this 3 because it's in the grouping symbol. And there's no way to just gone the grouping symbol other than transforming it into a compound inequality. Now with this, I still don't have a great way to proceed with this, but I'm going to try and clean it up there by distributing that negative and then see what can be done. Now, I'd like to get all the t's in the middle so I can get an inequality solution with just t in it. But the thing is, if I work with let's say subtract t to get it off of this side. Subtracting t will make this one even bigger. So I think with this one, it's a good place to split this compound inequality into the two components of what it means. It's like a run-on sentence. Is less than or equal to, is less than or equal to. It's got two verbs. But as a mathematical statement, it's good. It's a sound mathematical statement, even though run-on sentences aren't good in grammar. What I'm going to do is negative t plus 7 is less than or equal to 3t minus 3. And 3t minus 3 is less than or equal to t plus 7. So I'm breaking down this compound inequality into two single or simple inequalities. I think divide and conquer works often enough that it's worth a try. So with this one, I can add t to both sides to get, those cancel and leave 7 less than or equal to 3t plus t is 14. Minus 3, and then we'll come back to this other one, but add 3 to both sides. I get 10 is less than or equal to 4t. Okay, if you wrote all this, you don't have to change very much, but what did I do here? I distributed incorrectly. That's not going to help in the long run. That's all I need to really get rid of, because it should be negative t plus 7 is negative t minus 7. I had to distribute the negative, and I didn't do that. The steps were fine, though. It's just at this point I should have negative 7, and when I add the 3 to it, adding the 3 to get rid of this minus 3, it's negative 7 plus 3 is negative 4, less than or equal to 4t. I still need to work on this one, so I'm going to have to continue this up here. Divide both sides by 4, and I get negative 4 divided by 4 is negative 1, less than or equal to 4t divided by 4 is just t. And that's not the complete solution, but that's part of what I need. I need to backtrack a little bit to the other piece. This was the inequality that I built, that I split into these two pieces. Now this one I'm going to solve in a similar way. Subtract t from both sides to get 2t minus 3 is less than or equal to 7. And then add 3 to both sides to get 2t is less than or equal to 10. And then divide both sides by 2. So that was kind of fast, but that's a simple inequality. 1, 2, 3 steps. When I cancel the factor of 2 here. Cancel the factor of 2 here. So this, you could say t is greater than or equal to negative 1. That's a kind of maybe a more comfortable or natural way to say it. But I really do want to work with it this way, because with that combined with this, I can make a single compound inequality. This is true, but I don't want to use that. It's hard to look at. So the t is above negative 1 and below 5. That's t is between negative 1 and 5. Or as a graph, negative 1 and 5 with brackets and shaded. And finally, as interval notation. Interval notation has the advantage that it's faster to read, write, and it's clearer and more concise. Okay. So I really didn't know how to do that one in an organized way, but I just, the only thing I could come up with was to split the inequality into two separate ones and work on them separately. So you may have to do that. The problem 9, I got 18 over 4 less than 4 times y plus 5 over 2 is less than 23. No. 18 over 4 is less than y plus 5 over 2 is less than 23 over 4. Whoa, that's a mouthful. Anyway, this looks a lot like that last fraction problem we did. Different though. That last one, when I simplified the numbers, the bounds or the bookends of the number parts, they were both whole numbers. This, well, we could get into decimals with these, but I think that would be even more complicated. The best thing to do here is to clear the inequality of fractions. And I'm going to do that by finding the LCM, or least common denominator, least common multiple, and then multiplying all 3 parts by it, and it'll just go away. There will be no more fractions. You might be able to see it already. The LCM of these 3 denominators is 4. Yeah, 4 is a multiple of 2. 4 is a multiple of 4. That's the smallest multiple of 4. That's as small as it can be. So rather than try to divide these, which I can't evenly divide them anyway, I'm going to multiply all 3 parts by 4. So 18 divided by 4 times 4 is 18. So let's say y plus 5 divided by 2 times 4. I'm just going to write that. If you can advance to the next step of this simplifying, that's fine. But I'm going to keep it simple for that step. 23 divided by 4 times 4 is 23. You got rid of the 4. There's a 4, but this 4 and this 2 cancel, leaving a 2. And that's what I meant by the next step, is just canceling that. So I have 2y plus 5 less than 23. Next, I want to distribute that 2. 18 is less than 2y plus 10 is less than 23. Next, I'll subtract 10. I'm trying to isolate the y variable. This gives me 8 is less than 2y is less than 13. And I need to go back up to the top. So at this point, I want to divide by 2 all 3 portions of the inequality. 8 divided by 2 is 4. 2y divided by 2 is just y, and that's it. We've isolated y. 13 divided by 2. I wrote here 6.5. I think it's because Hawks said to use decimals. But if you want to put 13 over 2, that's reasonable to me. They might want you to use decimals because of the way the number line works in Hawks. Sometimes they have number lines that have changing fractions, and they're a little hard to follow because the denominator keeps changing. But with decimals, it's a great way to move up and down the number line. You can watch the hundredths change really fast, and you watch the tenths change, and the numbers change slowly. But for this one, it's between 4 and 6.5 with parentheses. And the interval notation is also between 4 and 6.5 with parentheses.